Hi, this is my experiment to show constant velocity in one dimension. Constant velocity in one dimension, we're trying to illustrate Newton's second law, which is force equals mass times acceleration, and the momentum principle, which is a variation of Newton's second law. Newton's second law, F equals ma, where F is force, m is mass, and a is acceleration. Acceleration is the change in velocity divided by the change in time, or how fast the velocity of an object is changing. The equation that I use is the position, since we're using one dimension, x equals the initial position plus the initial velocity times the time plus 1/2 the acceleration times time squared. Now, since we're trying to do constant velocity, there is no acceleration, or the acceleration term is 0. So the position is equal to the initial position plus the velocity times the time. We can also calculate the velocity of the object from Newton's second law using that velocity equals the initial velocity plus acceleration times time. Once again, since we're doing constant velocity, acceleration is 0, and the velocity is a constant. The final velocity equals the initial velocity. The momentum principle is just a slight variation of what we did with the preceding example of Newton's second law. What we did is use force divided by mass instead of just straight acceleration. So the final velocity is equal to the initial velocity plus the net force divided by the mass times the time. Now, since the velocity is 0, the velocity is not 0, the net force is 0, which implies that the acceleration is 0. So, there isn't going to be any change in velocity. But going through with the equation, if we multiply both sides of our initial equation by the mass, we have mass times final velocity equals mass times initial velocity plus net force times change in time. Here's my experiment. I had a steel ball I rolled on a level table. I put a meter stick behind it so I'd have a sense of scale. I only ran it for a short period of time. Right about here is where I track the initial position. I use the reflected spot, so I choose the same spot on the ball as it rolled across the screen. There goes the ball. If we look at the graph created by Tracker, we can see that the velocity of the ball is equal to the slope. The vertical axis is position, and the horizontal axis is time. If we take the slope, which is rise over run, we calculate the velocity. I used Excel to do a linear fit to the data and calculated that the velocity was 70.55 centimeters per second. I plotted on Excel the observed data in blue squares and the model data in red squares and overlaid the two data. As you can see, there's very little difference between the two. My conclusion is, for a short period of time, the frictional forces had little effect on the velocity of the ball, and the ball rolled with constant velocity. This meant that the net forces were very close to 0, and that's why I had a good fit between the data and the model. Thank you very much.